Here's a question that trips up a lot of calculus students. What is sine of x divided by x as x approaches 0? Plug in x equals 0 directly and you get 0 over 0, undefined. But that doesn't mean the limit doesn't exist. Let's actually see why it equals exactly 1. If we plot f of x equals sine x over x, the curve looks perfectly smooth everywhere, except right at x equals 0, where the function isn't even defined. There's a hole. The question is, what value would fill that hole in perfectly? Before we get rigorous, here's the intuition in one picture. On a circle of radius 1, the arc from angle 0 to angle theta has length exactly theta. Drop straight down from the end of that arc to the x-axis, and that straight segment has length sine theta. Right now, those two lengths, the curved arc and the straight drop, look pretty different, but watch what happens when we zoom in close to where they meet, right as theta shrinks towards 0. Any smooth curve looks straight once you zoom in far enough. That's what it means for a curve to be smooth. So down at this scale, the arc and the straight drop become impossible to tell apart. That's the intuitive reason sine theta and theta themselves become essentially equal for small theta, not just their ratio approaching 1, but the two quantities visually collapsing into each other. Now let's make that rigorous. Forget the zoomed-in picture for a moment and look at the full circle of radius 1. Pick a small angle theta. That gives us three shapes stacked inside each other: a small triangle, a circular sector, and a bigger triangle. The small triangle has two sides of length 1 and an angle theta between them, so its area is 1/2 sine theta. The sector, that pie slice shape, has area 1/2 theta, because that's just the fraction of the circle's total area cut out by the angle. And the big triangle, formed by the tangent line, has area 1/2 tangent theta. Since the small triangle sits inside the sector, which sits inside the big triangle, their areas must be ordered the same way. Watch what happens as theta shrinks towards 0. The three shapes get closer and closer together. That area comparison gives us, sine theta is less than theta, which is less than tangent theta. Divide everything by sine theta, which is positive for small theta, and we get, 1 is less than theta over sine theta, which is less than 1 over cosine theta. Now flip every term. Taking a reciprocal reverses the direction of an inequality, so, cosine theta is less than sine theta over theta, which is less than 1. Here's the key move. As theta goes to 0, cosine theta goes to 1. So both the left and right walls of that inequality are closing in on the value 1, and sine theta over theta is trapped in between them. That's the squeeze theorem. When a quantity is sandwiched between two things that both converge to the same limit, it has no choice but to converge there too. Watch the dot on the graph slide in from the side, and land squarely on 1. That's the value that fills the hole. The limit of sine x over x, as x approaches 0, is exactly 1.